Okay, number one, you got to interpret what they want you to do. So this guy right here is going to show up on the test either h of x times g of x. Wow, this pen is awful. So h of x times g of x, or it's going to be written like this. Either way is the exact same thing. This is what they're communicating. They want you to multiply them. So they want you to take h of x, which is x plus 5. This is my h of x. And all they want you to do is multiply it to g of x, which is a negative 3x squared plus x. So here's my g of x. All they want you to do is times them. But since h of x has two terms and g of x has two terms, you've got to distribute. You got to multiply each term by each term. X times negative 3x squared is going to be negative 3x cubed. X times x is x squared. 5 times negative 3x squared is a negative 15x squared. 5 times x is 5x. So you multiply and you end up with 4 terms. Of those 4 terms, your center two are like terms. You can combine those like terms. What's x squared minus 15x squared? So your final answer is this. You should have a negative 14x squared. You should have a negative 3x cubed. And you should have a positive 5x. The order of those 3 terms does not matter, but you got to have those 3 terms. Number 2. Okay, tell me when. Alright. Okay, number 2. All they want you to do is subtract. Number 2 is a subtract problem. So you're going to take h of n, which is n plus 5. Put it in parentheses. This is h of n. And then you are going to subtract g of n, and just like they wrote it. Put it in parentheses, n squared minus n. This is g of n. Okay, now subtract is going to be a little bit easier. Because add and subtract, all you got to do is like terms. Combine like terms. But here's the number one thing you got to remember. If you're subtracting g of n, you are going to subtract the n squared. And you are also going to subtract the negative n. So I would take that subtract to both those pieces first. And it's going to make this n squared a negative. But what's it going to do to the negative n that's already negative? Should make it a positive. So now I've got this term and this term. I've got 4 terms. I don't do anything but combine them. Which ones can I combine? Your first and your last. N and n. And you should total those and end up with 2n. You got a plus 5. And you got a minus n squared. So the order of those 3 terms doesn't matter, but the signs do. So positive 2n, positive 5, negative n squared. Any questions on that one? Okay, number 3. This is where we were last week. On the final, here's what I want to see. I'm going to check for 4 points. I want to see a table. And I want to see these 4 points. I want you to check these very first 4 perfect squares. Square root of 0, square root of 1, square root of 4, square root of 9. Okay, now, follow your steps. You've got them written down somewhere in your notes. Use your notes. You ignore anything on the outside, so cover up this plus 2. Ignore it. All you're staring at is right here. Underneath that radical, you want to have a 0. But whatever you plug in, you have to add 6. So what number add 6 is going to end you up at 0? What is it? Your very first entry in your table has got to be negative 6. If you do negative 6 plus 6, you get a 0. What's the square root of 0? And then after you've done that, you have to plus 2. So 0 plus 2, there's your very first dot. Negative 6 and 2 are a pair. So you're going to go left 6, you're going to go up 2. Now, what can you plug in that's going to give you underneath the square root a 1? So what number add 6 is a 1? Negative 5. So negative 5 plus 6 is 1. What's the square root of 1? And then so here's what we got. Negative 5 plus 6, square root of that. That's 1. Square root of 1 is just 1. But then you have the plus 2. So it should give you a 3. Negative 5 gives you 3. So go left 5, up 3. You got a dot. Okay, next. How am I going to end up at a 4 under the square root? What number add 6 is going to give you a 4? Negative 2. So you are going to put negative 2 in for x. Well, what's negative 2 plus 6? It's 4. What is the square root of 4? 2. But then at the very end you have to add 2. So where are we? We are at 4. So go negative 2 up 4. You got a dot right there. Last one. Let's check for a 9. What's going to give us a 9 under there? Plug in a what? Plug in a 3. 3 plus 6, that's square root of 9. Square root of 9 is 3. At the end you got to add 2. So 3 is going to give you a 5. So go over 3, up 5. Okay, now on the test, you're going to have to tell me the domain and the range. So you're going to start right here, and it is going to go forever this way. It's going to go to the right, and it's going to slowly gain in altitude. But what happens to the left? Nothing happens to the left. You cannot go any further left than negative 6. Because if you go to a negative 7, you're going to have square root of a negative 7 plus 6. You're going to have square root of a negative 1. And square root of any negative is in some imaginary world. So, let's talk about domain and range. What is the domain? Domain is left and right. What is the very farthest left you can go? Cannot go any further left than negative 6. What's the farthest right this is going to go? It's going to go all the way to infinity. But you can never include infinity, so parentheses. But do we include negative 6? If you include negative 6, put a bracket. Okay, the range. What is the smallest, the very furthest down this is going to go? It is not ever going to go any lower than right there. So it is going to go as low as 2. But what is the highest it's going to go to? All the way to infinity. Is 2 included? So put it in a bracket. Okay, number 4. Let's do this. Let's say that it is, let's say greater than. So change that to greater than. Okay, the same thing. I'm going to check your 4 points. I'm going to see a table, an X and a Y. So what is the very, very, very first point you're going to put in for X? What's the smallest X? It cannot go any further left than 2. So if you plug a 2 in, what's 2 minus 2? What's the square root of 0? But then when you're all done, you have to add a negative 2. So what's 0 plus negative 2? So if you plug a 2 in, it should give you negative 2 out. So go over 2. Go down 2, put a dot. Okay, what are you going to plug in after 2? You're going to plug in a 3. Because whatever you plug in, you have to subtract 2. What's 3 take away 2? You just created a perfect square. What's square root of 1? But then you have to do 1 plus a negative 2. What's 1 out of negative 2? So 1 is going to give you negative 1. So go over 1, down 1. Hold on, did we mess up? We didn't plug in a 1, we plugged in a 3. So I gotta take that dot away. And I gotta put a new dot right here. So over 3 and down. Well, there we go. Okay, what are you gonna plug in after 3? 6. So if you plug in a 6, the first thing you have to do is take away 2. What's 6 take away 2? What's the square root of 4? And then 2, you have to add a negative 2. What's 2 add negative 2? So when I plug in a 6, it gives me a 0. So go over 6 and 0 dot. Last point I'm going to check for. What are you going to plug in next? 11? If you plug in 11, you have to take away 2. 11 take away 2, that is a perfect square. What's the square root of 9? 3, and then you have to add a negative 2. What's 3 add negative 2? So if I plug in an 11, it gives me a 1. 11 does not quite fit, so you gotta come off. Okay, now, do I connect those dots with a solid line or a dotted line? Why does it have to be a dotted line? Because it's not inclusive. Your answer is anything greater than this line. So anything greater than that line is shading above it or shading below it. Shading, because it's greater than, it's bigger, you have got to shade everything on top of this line. Your answer can be anything above the line. Your answer cannot be on the line. If it was greater than or equal to, then it would be a solid line. But you cannot shade anything to the left of 2. So draw your line right here on 2, and this stuff over here is imaginary. Okay, the domain and range. Let's talk about the domain and range. The domain, what is the very farthest left it goes? Does it include 2? Yeah, and you can include 2 up here. So 2, let's put it in a bracket. What's the farthest right it goes? Infinity. Parentheses. What about the range? How far down? What's the lowest it goes? Negative 2. Does it include it? Does it include it? That is a trick question. What about the farthest up it goes? Is parentheses. So I won't give you a question that's tricky. I'll make the one on the final easier. Does it include a negative 2? So the very, very farthest down has got to be negative 2, which is this point right here. But it cannot be on the line, so I think Parker's right. I think it's a no. I don't think it includes. I think this has got to be parentheses. But see, the domain, it does include 2, not on the line, but look at all this. It could be up here at 2, but it cannot be on the line at 2. So I'll make it easy on the final. So you guys try these next ones. Try this one. So if you're looking at this number line, interval notation is using the parentheses and brackets. So what numbers are included in this set? The smallest number is going to be something dang close to negative 3, right? Negative 2.999999. Negative 3, because it's empty, is not included. So it's gonna, the number right next to negative 3. What number is right next to negative 3? That's a bonus question. What number is right next to negative 3? Is there a number? Any number you choose. What will I choose? I can find one smaller. This is an excellent bonus question. So if you tell me what number is next to negative 3, if you say negative 2.999, what will I say? Negative 2.999. So you can give me any number. What if you give me 1,000,000 nines? What will I give you? 1,000,000 ones. So is there a number right next to negative 3? Jade, what do you think? On the number line, is there a number right next to negative 3? Yeah, it would be negative 2.9 with a bar over it. But kind of in theory there is, but in real life there's kind of not, because any one you choose I could give you one smaller. So anyway, that's good for the bonus. That could show up on your bonus. So negative 3 is going to be hugged with the parenthesis because it's not included. So negative 3 all the way up to 5, but 5 is a bracket because 5 is included. So that's interval notation. Question number 1. The integers are all the negatives. Negative 3, negative 2, negative 1, 0, 1, 2. Those are the integers. So how many integers are from negative 3 to 5, not including negative 3? So there's negative 2, negative 1, 0, 1, 2, 3, 4, 5. There should be 8. Okay, the naturals. The naturals are 1, 2, 3, dot, dot, dot. Smallest natural is 1. How many naturals are there? 5. The whole numbers are 0, 1, 2, 3, dot, 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 to infinity. So how many wholes are there? 6. Okay, the rationals. Rationals are fractions. 1/4, 3/4, 0.5. If it's a decimal that can be written as a fraction, it's rational. So how many fractions are there from negative 3 to 5, not counting negative 3? There's infinity. How many fractions are there just between 0 and the number 1? Infinity. Infinite amount. Infinity sign, that's fine. How many irrationals? Okay, the irrationals are pi. They are decimals that go on forever with no pattern. Pi, square root of 2, square root of 3, square root of 5, square root of 7. Yeah, there's the same thing. Infinite amount, infinity. Okay, the real numbers are this. It's abbreviated with a capital R. It means all of the above. If it's a real number, it's any one of these numbers. So again, same answer. How many imaginaries are there? None. There's 0. Because this number line, this is a real number line. Gosh dang it. Hit this marker. So it's a real number line. So there's no imaginaries on that number line. That number line only has real numbers. So that's kind of a trick question. Next. Okay. Find the roots. That means solve it. Find the quadratic equation. Move number 1. Get everything on the same side. 3x squared minus 7x minus 30 equals. You got to clean this up right here. Distribute the negative 2, so it's going to be 2x squared minus 12x minus 6. That is your first move. Now I'm going to move everything to the left. I'm going to take this over. So I'm going to minus 2x squared. Minus 2x squared. You're going to have 1x squared minus 7x minus 30 equals minus 12x minus 6. Now I'm going to move those other two to the left. I'm going to undo them. I'm going to add 12x and I'm going to add 12x. You are going to have x squared plus 5x minus 30 equals negative 6. I'm going to plus 6 plus 6. After a little bit of algebra, here's my move. I am at x squared plus 5x minus 24 equals 0. And most of you guys got to that point. So are we good to there? So you get all your terms on the same side. On the other side, you want a big fat 0. Okay, I'm going to erase this. Can I erase all this? So here's what I got. I got x squared plus 5x minus 24 equals 0. Okay, you're going to have to use quadratic formula. A, B, C. Unless it's factorable. Can you factor this? If this is factorable, then we're a piece of cake. Does there exist two integers that multiply and give you a negative 24, but at the same time add and give you a 5? 8 and negative 3. Okay, this just saved our lot of work. Now here's the hint. Because my x squared started with the 1, anytime this starts with the 1, I always check to see if I can factor it. Because if this starts with the 1, then factoring is usually pretty easy. So the question is, can I times two numbers end up at negative 24, add them and end up at 5? Your answer is yes. So if you find them, you're going to do this. You're going to rewrite this as a times problem. It's going to be x plus 8 multiplied by x minus 3. Your answer is 0. So what must your solutions be? Your solutions have got to be a negative 8 or a positive 3. Because if you plug a negative 8 in there, it's going to give you 0. 0 times this quantity is 0. And if you plug 3 in there, it's going to give you 0. So that one was actually very intimidating to look at, but it's actually pretty easy to do. Not bad. 7. Which one of these is linear, quadratic, exponential? Okay, this first one is going down 2 every time. This is a constant rate of change. This is linear. Okay, this one right here in the very far right, 4 to 6 went up 2, 6 to 12 went up 6, 12 to 22 went up 10, 22 to 36 went up 14, 36, 18. This one is familiar to us too. Look at this. Now I got to analyze my change again. But how much is it growing from 2 to 6? Up 4. What about 6 to 10? Up 4. What about 10 to 14? Okay, my second time around, it's constant. This would be a quadratic. Quadratic is x squared. Linear is x to the 1. So the quadratic, because my second change is constant. So by default, this middle one has to be exponential. And as I look at this, this is kind of a mean exponential. I'll give you an easier one in the final. 1 to 3 went up 2, right? 3 to 9 up 6. How much from 9 to 27? You're just timesing it by 3. This went up 18. This went up 54. This went up 162. This went up 486. Okay, now do it again. How much from 2 to 6? Up 4. How much 6 to 18? 12. Is that 12? How much 18 to 54? 36. How much from 54 to 162? 108. How about, is it 324? Okay, 4 to 12. Up 8. So what's going on here? On the exponential ones, you can keep going forever and ever and ever, and it's never going to become constant. So this guy, I'm going to say, is my exponential. And it looks like this. Y equals, this one's tripling every time, 3 to the x. Goes forever, never ends. Okay, last one. Same one as we just barely did. I'm going to get everything to the left. I'm going to minus this over. I'm going to minus 9k squared. Minus 9k squared. Oh, you know what we forgot to do? Put them on a number line. So what's 12k take away 9? 3k squared plus 12k equals 12k plus 4. Minus 12k minus 12k. So do I got 3k squared equals 4? Minus 4 minus 4. I got 3k squared minus 4 is 0. Now I got everything on the same side. So as soon as I got everything on the same side, 3k squared minus 4. Let me erase. Can I erase all that? Can you factor that one? Or are we going to have to go quadratic formula? There's what I got. 3k squared minus 4. I'm going to go quadratic formula. A, B, and C. What's A? A is 3. What's B? There's not a B. B is 0. C. So A, x squared, B, x, C. A is the number in front of the square. B is the number in front of the x, but there's not one, so that's why we put it as 0. But C is just a number by itself. So here we go. X equals negative b plus or minus the square root of b squared. On the test, put b squared in parentheses. If you don't put that in parentheses, you're going to miss it if you're using the calculator. If you're doing it in your head, that's another story. But if you use the calculator, put that in parentheses or you will miss it. B squared minus 4 times A times C all over 2A. Okay, now it's calculator. Underneath that radical, if you punch that in on the calculator, what does it clean up to? Negative? Positive? What is it? 48? And on bottom you've got, sweet. Okay, is 48 a perfect square? Do square root of 48. Is it a whole number or a decimal? If it's decimal, that sucks. Square root of 48. You're going to have to pull some stuff out. 48. Let's factor it down. What times what's 48? 6 times 8. 3 times 2. 8 is 2 times 2 times 2. You're going to trade 48 for this. You're going to go plus or minus the square root. How many 2's we got? 2 square to the 4 times 3. And then on bottom we just got 6. So because it's a square root, you can pull things out if you got 2 or more. We got to pull them out in groups of 2. So how many 2's are going to come out? We got, so you got this on the outside. So let's go plus or minus. We got 2 groups. We got 2 squared. What is 2 squared? 4. So you got 2 squared. On the inside, all the 2's came out, right? You got a 3 still left in there. And on bottom we got 6. So we have got plus or minus 4 times the square root of 3 all over 6. What is 4/6? So your final answer, plus or minus 2/3? Plus or minus 2 times square root of 3 over 3?